this is who I am, and you're all welcome to contact me if you'd like to discuss any of this further. And of course, I'll welcome questions. And if something burning comes up while I'm talking, you're certainly welcome to raise your hand, and we'll do the best we can to answer it. There isn't all that much data. Part of the problem of getting data is, from this point on in your career, it's not like being in college where you say, I start, in September, and I tell my parents, to buy their tickets for graduation 4 years later because that's what's going to happen. Things don't happen in sync, and some people do a postdoc, some don't. Some do one postdoc, some do two. Some do a 1 year postdoc, some do a 7-year postdoc, which no one should really do, but it does happen. And so when you ask, well, how many PhDs actually go into academia, meaning basically a tenure track position, it's hard to get the numbers because some may be going in very soon after they graduate and some may be going in quite a while later. But in those surveys that have been done, it seems like since the days when I was in graduate school, the percentage of people going into academia has declined. And the most recent number I could find was 2012, and they calculated that it was 21% of people who get a PhD actually get a tenure track position. And that was in 2012. It's probably lower today. Now that lowering trend is not necessarily a bad thing, because what that means is, the bad way of looking at it is say, wow, I'm training for a job that I have an 80% chance of not getting. That's not a good thing. But on the other hand, what it also means is there's lots of opportunities out there. The unemployment rate for PhDs is phenomenally low, and the overwhelming majority of them are still working in science or science-related fields where they're applying the skills they've developed in getting their degree to do something very useful for society. And what's happening now is that more and more PhDs are getting jobs outside of academia, not necessarily because they failed to get an academic job, because many of them, because they said, wow, that's a more interesting job. That's something I want to do. And so that's something you have to think about. But of course, it's hard to think about it if you have no idea what's going on out there. So if there's one lesson I want you to take away from this, is whether you're going into an academic or non-academic career, or you're not sure, it's a very good idea before you graduate, long before you graduate, to start thinking about these things so you're ready. Because if you graduate, you say, well, I've got my PhD, now I'm going to go out and get a job. Well, it turns out there's a lead time for that, and if you haven't been thinking about it, you're going to wind up spending a lot of time looking before you get a job. And I don't know what life is like for you, but in my life it's always been, well, if I'm not working, I'm not eating, so I better be working. Okay, so there are great opportunities for you to get a PhD. You realize that as a PhD, you're not just learning, your specific research problem, but you developed a tremendous bunch of skills. You're able to solve problems. You're able to analyze huge amounts of data. You can write. You can organize writing. You can communicate verbally. You can learn from other people. You can teach other people. There's a lot of things that you're able to do that are in demand in many areas of the workforce. So a lot of people want PhDs to be hired. So the question is to find the area that you're interested in working in. Now, there are a lot of opportunities, and any list we make is going to be incomplete because this is very individual. And there are some jobs where there may be only one of a kind and you get it, and there are others where there are tens of thousands of these people and you'll be one of them and you're happy to be them. But I've kind of broken this down into the pharmaceutical biotech industry, which is I think an obvious thing, where the skills you've learned are directly applicable, but also patent law and technology transfer is a huge area. I don't know, have any of you been involved in patent applications? Okay.
Someone who wants to have a weighted last year?
I have not yet been involved in making money from patent applications, but hope springs eternal. Journalism and authorship. You can write. Very few people out there can really do that well. Funding agencies need you. When you talk to people at the NIH, the NSF, Department of Defense, the various federal regulatory agencies, or even Cancer Society, people like that, you're talking to people with PhDs by and large, and they're working in those situations. Scientific societies hire PhDs. It used to be that scientific societies had elected presidents, vice presidents, etc. They served for 1 year and then rotated off. And those people were kind of figureheads, and they may be very important in terms of planning the annual meeting, but in terms of actually making the society run, and many societies either have grants they've received from federal agencies, or maybe they have funding where they make grants to people or give travel awards to people. A lot of that work has to be done by someone who knows what's going on in the world of science, but is actually an employee and not just a person who wrote, the president of the society is not going to sit down and look at these 5,000 people who have applied for a travel award and decide who gets it. There's going to be some administrator who's going to help working on that. And it really helps that those administrators have scientific background. It used to be that those people were basically, secretarial or accounting people who got hired. More and more now, a lot of these people are PhDs. And so those are big jobs. Pre-college education, again, high school and of course also primarily undergraduate institutions may not be quite the same as a research institution, but they hire a lot of PhDs. And a lot of people I know, as they're going through school, find that they really like the science, but they enjoy teaching the science more than they enjoy working in the lab. And there's room for that, and there are opportunities there. Science policy advisor is another area, and of course there are jobs in science museums and libraries. So there are a lot of opportunities out there where you can get jobs if you know they're there. Now, in the pharmaceutical and biotech industry, there you're again doing science. You're working in the lab and solving a problem. It's not all that different from being a scientist in a university, but except that you're in university. If you're a faculty member, you can kind of say, "Well, this is my lab." You walk in on day one, and you have this big empty room, which you hope you'll get grants to fill with equipment and graduate students and all that good stuff. And you say, "Well, what do I feel like working on?" Probably something you've already thought about quite a bit. And then you do that, and if you're funded, you can keep working on it. Well, in the biotech industry or pharmaceutical industry, they have an interest. They want to develop a particular drug. They want to develop a particular test. They have a particular problem they want to solve, and they want you to do that. And you don't get to pick it, but once you get your head wrapped around that, it's really wonderful, because then when you want to start working on that problem, they're very, instead of you asking, "Well, can I buy this thing?" They say, "Buy whatever you need. We want you to solve this problem. We don't have to write a grant. Just put in a purchase order." So it can be a wonderful thing, but of course, one day, the company may say, "Well, we've been working on cancer for a long time, and I think we're going to change our focus to hypertension." So again, you have to be flexible, but there are opportunities there, and it can be really great research. Some of these companies hire research staffs who could be faculty at any university. In fact, there are some people who've gone back and forth in their careers between companies and academia almost seamlessly. So the quality of the research may be quite similar. Now, one thing you may think about, and you may want to look into this if you're interested in the pharmaceutical or biotech industry, is some of these companies actually hire postdocs. And that can be a great way of breaking into the company. You work there as a postdoc, and just like in the university, if you're a really great postdoc, maybe they'll offer you a professorship, or at least you'll have the credentials where you can go to another company or another university and get that kind of appointment. If you're going to go into a postdoc program in industry, the one warning I give you, I've had a number of friends who've done this with very good results, is just look first at what you're getting into. Because when you're a postdoc in academia, it's like being a graduate student, but better because you don't take courses and you get paid more, and you have graduate students to work for you. But the criteria is I'm going to publish, and the more you publish, the more successful you are, and the better your CV is, and the better your opportunity is for either staying there or moving elsewhere. Very often in industry, some postdocs are just like that. They want you to publish because every time you publish, that's an advertisement for their product. On the other hand, sometimes in industry they say, wait a minute, we're doing this research to develop this new drug, and we don't want anyone to know what it is we're doing. And we don't want you to publish. We just want you to write a report for us. And don't, if you publish it, we're going to fire you because you've broken your confidentiality agreement. Remember, to get patents, it has to be knowledge that wasn't previously in the public sector. And of course, in industry, there are also some products that aren't patented, that are proprietary, where they say, we know how to do this thing. No one knows how we do it, but it's wonderful. And we're not going to tell anyone how we do it. So again, when you go into these programs, in a postdoc program in industry, you want to find out what the rules are. Will I be free to publish? Can I talk about my work or not? Now, I have a friend who went to work for a major pharmaceutical company, and they told him, you're never going to publish anything. He eventually became vice president of the company. He was very successful. But of course, if you want to go to another company, he would have to say he couldn't talk about the research he did because he had signed the confidentiality agreement. So, again, that's something to consider. But of course, there are also many non-research positions where your title doesn't sound at all like anything you've heard of in academia, but where you're still using the skills that you know as a scientist. Because people who run the company, not working in a lab, but in the corporate side of it, have to know something about the science and have to be able to analyze large amounts of data and have to be able to communicate. And those are things that you can do. And on that side, of course, there's probably even more opportunity than on the research side for advancement into management, if that's your goal. So, I found a list online where they had the 10 top jobs in industry that were non-research jobs. And a lot of these are things that you wouldn't think about, just from being in the lab, like a market research analyst. You have a person who looks at the competition, looks at the product your company produces, and analyzes them based on their merits to see, which is better, how do we make our product better, or maybe is this an area we should get out of, not make our product better, because these guys have it sewed up. A business development manager prioritizes the innovative products. So your company is working on several different projects. Which ones have the most potential in the marketplace, both relative to what is the need for this product and what is the competition in that area? Again, very complicated problem. Again, corporate intelligence is simply analyzing competition. One area that a lot of PhDs go into is a product manager. You think about it, in a company, they may be doing some very basic research on the way to developing a class of drugs. They may be having drugs that are in preclinical testing on animals. They may have things that are in clinical trials. They may have things that are going past clinical trials and on to being investigational new drugs, to getting licensed for use. Then they're being marketed. There's post-market analysis. If there's side effects, there's new uses, off-label uses. they have people called product managers, and they will work on a particular product or class of products and follow them through their entire life cycle. And that requires a person who has a great deal of scientific knowledge, but also the ability to integrate that knowledge into the whole regulatory structure and business structure of what's going on. And those are product managers. And that, again, those people are usually PhDs or PharmDs who've had a lot of training. There are management consultants who do troubleshooting. A lot of quantitative analysts, a lot of, just like you look at genomic data, companies are looking at a lot of other kinds of data as well, often huge amounts of data. So a person who has a lot of ability to manage data can be useful to them because those skills are transferable. And a lot of times it may not be a thing you think of. Like my son happens to be an electrical engineer. And when he graduated, he said, about a third of the guys in my class didn't go into engineering. They went to Wall Street because they were good at doing computer analysis of huge amounts of data. And the guys running investment companies wanted to analyze huge amounts of data. So they'd go and hire electrical engineering graduates who were good at that. So it's, you never know. There are other areas where you can apply the same skills. And another area that you might not think about is medical communications specialists. In the programs I've been involved in, we've got a number of graduates who've become writers for companies. And the company has to, write instruction manuals. They have to write, they have to communicate with patients. They have to communicate with clients. They have to communicate with medical professionals. And there's a lot of need for people who can write in a way that whatever that target audience is can receive that information and understand it and find it useful. And that may be for different audiences. So they, again, will hire PhDs who have good writing skills. For those of you involved in computer technology, there is now a huge move that is well underway, but continuing, to take all healthcare data and convert it into electronic format. And again, people have to be hired to do that. So there's a huge amount of hiring going on there. There's work on data mining by operations research analysts, and medical science liaisons discuss medical and scientific issues with MDs or with PhDs. In fact, I had a student in my lab who, in fact, did her undergraduate work at UP Rio Piedras, and she went to work for GE Healthcare. Makes big scientific and biomedical technological equipment. And what she's got a job like this, a technical liaison. And so what happens is someone buys some multi-million-dollar system from the company, and they bought it to solve a particular problem, and they have problems getting the problem solved. So they call up the company sends her over, and she goes and works with them, often for several months, solving the problem using the piece of equipment that she's an expert at using. And so she gets to work on this project. I know I talked to her about this. She said, I really like this because I work really intensively on a project for 3 or 4 months. I get to the project to the point where the investigator can solve the problem. And then I go back to the company and I wait for the next call. And I'm working on a different project every 3 or 4 months. She said, I enjoy the variety. I'm not doing the same thing all the time. So there can be advantages to that. I asked her about I don't want to go back to academia. I like moving around. So something to think about. Okay. Intellectual property is a big area. It's something, again, that most of us in academia don't think that much about. If you're at a major university, what will often happen is you'll have a technology transfer office in the university. They'll periodically, even if you don't contact them, they'll contact you. And they'll say, well, what are you working on? And could this have any practical applications which might be patentable? And it turns out that that's how I wound up getting my patents, because I didn't even think about getting patents at first until I realized these guys were interested in doing this kind of thing. Now, in terms of getting patents and working on patents, there are two types of people who do this: patent lawyers and patent agents. And they both do the same thing, except lawyers can walk into a courtroom. Patent agents can't walk into a courtroom. And because the lawyer has to have a law degree, and actually doesn't probably have to have a law degree, but has to pass the bar, which is kind of hard to do without having a law degree. But in fact, in terms of a lot of the science of developing a patent, it really requires a scientific knowledge. It'd be very hard for a law school graduate who haven't had any scientific education to write a patent. And a friend of mine is a patent lawyer, and in fact, she only works on patent law because she's become like a scientist. She's learned the science after she learned the law. But on the other hand, you guys all know science, and the law is simpler than the science, especially if you're focusing only on patents. So a lot of these, both patent companies and technology transfer offices in universities, hire lawyers and patent agents to work on developing patents and licensing patents and defending patents. And here you have to, when you're writing a patent, you have to look at, what is my invention? Has the invention been reduced to practicality? Is it really new? Is it not obvious from the existing literature? There's a whole set of ways you have to think about it. What are the claims, and how do I defend those claims? And you can phrase the claims differently, because if you make the claim too narrow, it may be easier to defend, but someone else may do something a little bit different and circumvent your patent. If you make it too broad, it may be rejected because they say, well, you can't patent biochemistry. You have to have something specific. So it's and again, as you get experience in this, you get to be pretty good at it. So basically, these are two. Of course, some of you may. It does happen. I noticed at the progress report for the RISE program, one of your alumni got a law degree afterwards. So now they could be a patent lawyer. But on the other hand, you could all be patent agents if you went through some training. Now, universities have technology transfer offices, major universities, and the reason why is they want to get patents. And as you're aware, when in fact you get a grant and you do research, the intellectual property is in fact not owned by you, but is owned by your university. But under the rules of most universities, you can get a cut of it if it actually makes any money. And usually it's actually spelled out in great detail in the employment contracts that no one reads when they get hired. But so anyhow, so the university really thinks it's great if you write a patent for a new drug that turns out to be a blockbuster and makes $1 billion. So they both contract out, especially the smaller universities will contract out to intellectual property law firms to do their legal work. But in fact, many of them also have technology transfer offices that both write patents and help to develop the patents and to develop the intellectual property. And they will hire patent agents and patent lawyers to work there. And very often they will also train people to do this work. And very often they'll have externships or some kind of training program where a student or recent graduate can work in that office, help them out doing the stuff they do, reading patents and reading the literature and figuring out what's new and what's not, and what's patentable and what's not, and in that way get trained for this job. So this again is something you can look into. There may be opportunities for doing that kind of a thing. Now, in scientific journals, obviously most journals in your specialties are don't really hire much in the way of writing staff. You know, you pick up a Journal of Immunology or something like that. It's mostly articles written by scientists at universities or research institutions, and the journal itself is mainly an editorial thing. They may have an editorial board that may do some columns and things, but they don't write an awful lot. On the other hand, you look at a journal like Science or Nature, and half of those journals will be articles written as news articles. Major newspapers like New York Times will have a science section, and they actually have a staff of full-time employees who are writing articles. And those people have to both be able to write and have to know science. So again, those are places where there are job opportunities, and there are often internships, like the AAAS has their mass media science and engineering fellowships, and those are opportunities to rotate through and spend some time at the institute at science at the AAAS, learning to write. And Nature has some similar projects. There are also internships at some universities, like University of California, Santa Cruz, and Yale Medical School have internships for science writing. So there are places where you can get trained to that. And there's also an organization called the National Association of Science Writers. And if you go to their website, they will give you lists of people who are hiring, people who are training, and kind of news about the job market in that area. So there are opportunities there to learn more about that. Okay, another area that you might look into is the staffs of the funding agencies who do grant administration, review, and program development. At the NIH, I don't know how many of you have seen the pink sheets that come out after your grants get written, but there's a whole bunch of people on there. Now, some of those people are the reviewers, and they're by and large people who come from the universities and go in there for 3 days and review and leave. But there's also people on those lists, the executive secretaries of the study sections, the program officers of the NIH institutes. And those folks are PhDs or MDs who are working full-time for those agencies, either supervising the review process or working in offices there developing programs. So one of the things that happens is, obviously the review process is one thing, but the other thing that will happen is you may have an agency, let's say the Cancer Society or the National Institute of Heart and Lung or whatever, and they may say, okay, what's the unanswered problem in our field, and what kind of a grant proposal should we put out to solicit people writing applications for this area? And maybe we want to phrase it in a particular way so we get applications addressing this particular aspect of the problem. So it's really an opportunity to be pretty creative. And again, it's by and large scientists working at these places who do that. The FDA has regulatory fellowships to prepare people for pharmaceutical regulatory jobs. That's a huge business. In fact, one of my PhD alumni from my lab spent his whole career as a regulatory expert in the pharmaceutical industry. And he worked for a major company. And whenever a new drug was coming up for approval, he would spend a year working on getting that drug approved, or maybe more than a year, and then move on to the next drug. And there's a huge amount of paperwork involved, but also a huge amount of science, because all kinds of questions get asked about well, what's the structure, how is it synthesized, what are the contaminants? What are the possible side effects of the drug? What are the possible risks for the contaminants? How do we assay this? Will all people respond to it or not? And if they won't, do we have to test people? A huge amount of work that goes into this. And there's, again, a tremendous demand for people with the ability to do that kind of work. There are little difference among the agencies. The NSF has a recent graduates program where they'll take people within 2 years of the PhD, and they'll train them in working at the NSF, and they might want to look into that. There's also a Presidential Management Fellows program that takes people and trains them part-time while they're in graduate school, kind of fly in, fly out, or do things online. But the other thing the NSF has, which is different than the NIH, is the NSF has rotators. So very often, at the NIH, when you like talk to your program officer from your grant, that program officer is an employee of the NIH. At the NSF, they're an employee of the NSF, but they may be a person whose career is working at the NSF, or they may be a person who is a university professor, just like us, who has rotated through the NSF and is spending 1 or 2 or 3 years there before going back to their university. So, and it's interesting, I've met a number of these people who've been my program officers for NSF grants that I've had, and they kind of like this because they get to see both sides of the business, and they're actually, it's a very nice program because what they do is when you go there, you're working there, and I think they figure you're working about 10 months a year for the NSF, and you have the equivalent of 2 months a year where they pay you to go back to university, so you don't have to give up your lab to do this. You're going back and forth. So you're working at the NSF, but every few months you go back for a week or two to your lab and clean up the messes, figure out what's going on. And it's interesting that when I've talked to these people, some have done this, had a very good time, said thank you very much NSF, goodbye, I'm going back to my real world. I've had found other people, including some of the people who went on to major leadership positions in science, who've said that working for the federal funding agency is more interesting to me than running my own lab, and they've stayed at the NSF, and they've resigned their university appointment and stayed on. So again, it's not just that you have to make your decision now, but you do have the option of making the decision later. Of course, private foundations also hire scientists. You look at someone like the American Cancer Society or the March of Dimes, and they will have scientists working on their staffs as well. But a lot of smaller foundations just don't have the wherewithal to hire that kind of staff. So there may just be fundraising organizations. So, but there may be opportunities there as well for you to look into. Okay, another area is scientific society administration, and I right now have a couple of grants that are in fact awarded to American Society for Cell Biology, and interacting with that society has been really been eye-opening to me, because most of the people I've been interacting with there, in fact, are PhDs who are full-time employees of the society. And many of the larger scientific societies hire a whole staff of PhDs who are doing administrative work, and they're permanently or semi-permanently not quite distinct from, let's say, the leadership of the society. So the president, the vice president, the secretary, all those people, they're kind of honorific positions. They may do a lot of work during the year that they're president or vice president or whatever it is they do, but then they rotate off and someone else comes in. But the staff is there all the time, and they have institutional memory, and they make the place actually run. And when you say I'm awarding these 100 travel fellowships, they make sure that the dollars get to all 100 people, get to the right people. And it's really very much like in many ways administering the NIH or the NSF. It's a big organization. Now, it's interesting that now that I've been working for about a decade with the cell biologists, it turns out I've worked with 4 or 5 different contact people who've been the main people working with me in my grants. Why has that turnover occurred? Well, it turns out that many of those people who work for the scientific societies, in order to advance their careers, wind up transitioning over to being program officers at the NIH. And in fact, the last 3 administrators I worked with in the Cell Biology Society are now all program officers at the NIH. In fact, one of them is a program officer on a grant I just wrote. So a little daunting, but so went from being her boss to being my boss. But you know, so that's one of the limitations, I think, of scientific society administration is very often a limited amount of opportunity for career advancement. So what winds up happening with a lot of those positions, I've also had some graduates from our graduate program who've gone into this kind of career, and many of them have, in order to advance, have either moved from one society to another, or have moved from administering for a society to administering for a foundation. These, of course, have to be kind of discipline specific, and probably most of you will not become administrators in the physics society or in the mathematics society, but they're not terribly specific. And I've known people who've gone, let's say, from plant biology to pathology to cell biology. Those kinds of transitions certainly can be made. So it's not totally specific, and there are a lot of opportunities there. It's something to think about. Science policy advisor is another position. When government needs, especially now, needs scientific advice, and they hire scientists to advise on policy. Now, I have a good friend, in fact, who comes from Puerto Rico, who is in fact worked for a number of years for the State Department as a science policy advisor, and he loved it. He traveled to different countries and met with scientists in different countries, helped to set up bilateral exchanges of scientists with different countries, and he found it very interesting. The thing he said you have to realize is you're implementing policy, you're advising on policy, but you're not making policy. So you're hired to do a particular job, and you can say, well, I think we shouldn't do that. No, that's not an option. But it is an opportunity to have input and to implement things and to really learn a tremendous amount about a lot of different areas. And there are fellowships in this area, both run by the American Association for Advancement of Sciences, by National Academy of Sciences, and by other agencies, by the state of California. So again, these are places where you can go get a fellowship. These may be an alternative to a postdoc if you're interested in this, or maybe something to do after a postdoc, but it's something to think about. Again, another thing most of us don't think about while we're in graduate school is pre-college education, high school education. Although when I think about it, some of my teachers when I was in high school had PhDs. And in fact, there can be exciting jobs in education, both in pre-college and in primarily educational institutions. And when you think about it, having a PhD in the sciences, especially in a scientific discipline, may make you a better teacher than a person, let's say, who has a degree in education, but hasn't learned that much of the science. Of course, you have to have some training in the sciences, but there are, again, a lot of opportunities there. We've had a number of graduates from our programs who've gone into this. Very often they've risen to become, department chairman and program directors in these schools. Again, you need some educational training. but you don't necessarily have to have a degree in education. One doctorate is enough. And there are opportunities both in public and private schools. One thing you have to be aware of, though, is that you're going to have to be, be prepared to have your CV sell you as an educator. And I think that's happening more and more even for academic jobs, where you need a teaching statement in addition to a research statement on your application for a job. And those statements are written as, give us a statement of your philosophy of education. They want a short statement, like 1 to 3 pages, not more than that. And they don't want specifically a recap of your CV. So you don't want to say, I did this, I did that, I did this, I did that. Just don't tell us that, you know that already. But on the other hand, you don't want to write an abstract teaching statement that doesn't somehow work in between the lines. By the way, I have a lot of experience in this area. So what you kind of do is you do your teaching statement philosophy, but you make sure somehow you imply that I've had these experiences along the way, but don't just rehash your CV. That would be a bad thing. One thing that you should be aware of if you're interested in education is, a postdoc is not usually exclusive from doing this, and the ERACTA postdocs, which are funded by the NIH, combine training in research and teaching. So these are postdocs where you spend 75% of your time in a traditional in the lab postdoc and 25% of your time learning education. And in fact, these postdocs tend to be highly productive in their research as well, but they're also developing the credentials and the skills they'll need for a successful career in teaching. So I think that's something that any of you who are considering this might want to think about. Science museums and libraries also hire scientists in many capacities. Now, some universities, you look at a place like the American Museum of Natural History in New York that has hired some world-class scientists as in their institutions. Steve Gould comes out as one there who was there, and those places are like universities. They do research, they get grants, they train students. They're really universities under their name. Others are not. And again, a lot of these places, hire scientists. There are also opportunities for being trained. But one thing to be aware of is almost every museum is willing to train you, but not every museum is willing to pay you. And if you're independently wealthy, I guess that's okay. I never pursued this as a student because I said, like I said, if I'm not getting paid, I'm not eating, so I'm not doing that. But the major places, the big museums, will hire people to do an externship, and there may be opportunities for a limited time externship where you can rotate through the program and see what's going on and decide, is this for me or not? Now, I know one thing that is in this RISE program, unfortunately, was put on hold temporarily because of a little weather condition you had 2 years ago, there is supposed to be a program where they offer students in the RISE program the opportunity to do a summer externship outside of academia. And hold that thought, it will be coming, I believe, but I don't think it's been implemented yet. But the real problem is that all of you face is you haven't had this opportunity, but there are opportunities you always have to meet people in the field. So if you think, well, gee, I might be interested in working for a pharmaceutical industry, I might not be. I might be interested in journalism, I might not be. What's this like? Find people who work in that area. When you're at a scientific meeting, go to the booths from those people. If you go to I know when I go to scientific meetings, there's always a row of publishers. There's row upon row of chemical companies and immunology companies and cell culture companies. Some of those people there are just salespeople, but some of them are PhDs who actually have worked on those projects. Talk to them. Find out, what do they do? What do they like about their job? What don't they like about their job? What do they see as going on in their field? What's going to be happening in the future? Is this a growth field, or are they just counting the days till their retirement and then they're not going to be doing it and they hope no one else will be either? How do they train to get that job? What did they have to do to get hired? What was looked at? Again, the question comes up here about postdocs. I've heard someone say, well, I want to work for industry, so I'm not going to do a postdoc. Well, it depends what you want to do in industry. For a lot of jobs in industry, that's true. It's not going to benefit you necessarily to do a postdoc if you already have the skills that the industry needs. But sometimes, especially if you're going into a scientific lab in the industry may say, well, gee, we'd much rather hire a person who has done more. And in fact, people get hired even at the faculty level, get lured away to industry. So again, you have to look at the kind of job you want and what's required for it. Do I need more training, or am I ready right now? For some jobs, you're probably ready, as soon as you get your PhD. For others, it'll benefit you to have more training, but then you have to ask yourself, what kind of training and where should I get it? Should I do an industrial postdoc, or should I do an academic postdoc and build up my credentials so I can move into industry? Explore training opportunities while you're in graduate school. There are the short-term internships, like I say, the summer programs where you can go, work in a patent office, especially in a university, or work, in a journal for several months. See what it's like. That's a great way of making contacts for later on, and a great way of just seeing, well, is this what I like, or can I do that, get it out of my system and say, well, that's nice, I'm never going to do that again. Take a look at that. And there are also specific training you get. I mean, some people get an MBA while they're in graduate school or after graduate school. Some do it even as undergraduate, their programs, but do that. There's also many schools, I know Rutgers University, where I was, had one. I believe many other schools do. They call a mini MBA, where they say, okay, we know you're not going to be a real MBA, but we'll have a program which maybe, takes a year or two, going only one course a semester, where you'll get some of what an MBA does, but we figure that all this technical stuff you've learned as a PhD takes the place of a lot of the rest. So it's a mini MBA, and that's very, very common among scientists who go into industry. The mini MBA can be a way of getting the training without having to say, well, I'm going to go to school full time without a fellowship for a couple of years. Most of us don't want to do that. And as I say, there are all kinds of programs, in patent law. There are various educational programs where you can, take a minimum number of courses and get certified as a licensed teacher. Very often these programs will vary depending on what state you're in, but it's and there are fellowships in policy and journalism that may be open to you. Again, should I do a postdoc? Well, the question is, do you need more qualifications? Pros and cons of industrial postdocs we've talked about already. Maybe an internship is better than a postdoc, depending on what you want to do. One program you should have to look into is the NIH BEST program, the broadening experiences in scientific training. These are programs, postdoctoral programs around the country. There are 17 of them, including one at UC Davis, where it's a regular postdoc. It's nothing, but it's at a place that has a whole constellation of programs specifically focused on non-academic careers. So you can be doing your postdoc in a good lab, but at the same time, just like you're in the RISE program now, you have all these distractions, but they won't be distractions. They'll be what you really want to do. And they'll often have choices. So you can say, well, I'm here, but I'm really interested in journalism. I'm here, but I'm really interested in chemical industry. And they'll help provide you with that training. And of course, the ERACTA programs. So there are, the postdoc and non-academic work are not mutually exclusive, but again, you have to ask the question, do I need more training or am I ready now? Do I need more experience to know whether this is what I want to do, or do I already know what I want to do and I'm going to just go after it? And that's what you have to decide. Okay, I'll be happy to answer any questions. Thank you.